Imagine controlling your laptop cursor using a joystick, completely wirelessly, with a tiny ESP32C3 board. And the best part, we will also add an OLED display showing connection status in real time. In this video, I will show you step by step how to build a Bluetooth mouse using the XIAO ESP32C3, a joystick module, and an OLED display. As you can see, the joystick moves the cursor smoothly. Pressing the joystick button, perform left click, and on the OLED display, we can see the Bluetooth connection status. This project uses a BLE HID mode, so the laptop recognizes it a real wireless mouse. Here are the components required for this project. XIAO ESP32C3, joystick module, SSD1306 OLED display, jumper wires, and breadboard. The ESP32C3 is a powerful, low-cost microcontroller with a built-in Wi-Fi and Bluetooth low-energy BLE. It is based on a 32-bit RISC-V processor and is widely used in IoT, robotics, automation, and wireless control projects. The ESP32C3 supports BLE HID functionality, allowing it to act as a device like a wireless mouse, keyboard, or game controller. It also offers a low power consumption, multiple GPIO pins, ADC support, UART, SPI, and I2C communication interfaces. Because of its compact size, wireless connectivity, and excellent performance, the ESP32C3 is ideal for smart home systems, sensor monitoring, wearable devices, and DIY electronics projects. Connect the VCC pin of the joystick module with 5-volt pin of the ESP32C3. Connect ground pin with ground. Connect the VRX pin with A0 and VRY with A1 pin of the XIAO ESP32C3. Connect the SW pin with D8 pin. Connect the VCC pin of the SSD1306 OLED display with 3.3 volt and ground pin with ground. Connect the SDA pin of the SSD1306 with D4 and SCL pin with D5. First, we need to install the required libraries. These required libraries are included for Bluetooth mouse functionality, I2C communication, and OLED graphic display. The OLED display is initialized with a resolution of 128 by 64 pixels. Then a BLE mouse object is created so the ESP32C3 can behave like a Bluetooth mouse. Next, the joystick pins are defined. The VRX and VRY pins are connected to the analog pins A0 and A1 to read joystick movement, while the SW pin is used to detect button press for mouse clicks. The variable center X and center Y store the joystick center calibration values. Since the joystick does not naturally rest at exactly half ADC value, these calibrated center values help remove cursor drifting. The dead zone value prevents small unwanted joystick movement, while the speed variable controls cursor movement speed. Inside the setup function, serial communication is started and the joystick button pin is configured as an input with an internal pull-up resistor. The OLED display is initialized using I2C pins 6 and 7. If the display initialized successfully, the text starting is shown on the screen. After a short delay, the BLE mouse is started using a BLE mouse.begin, which enabled the ESP32C3 to advertise itself as a Bluetooth mouse device. Inside the loop function, the code first checks whether the laptop is connected through Bluetooth. The OLED display continuously showing either connected or waiting, depending on the BLE connection status. If the mouse is connected, the joystick analog values are read using analog read. The code calculates the offset from the center position and determines cursor movement direction. If the joystick movement exceeds the dead zone value, the cursor move left, right, up or down using the BLE mouse dot move function. Finally, when the joystick button is pressed, the ESP32C3 sends a left mouse click command using BLE mouse dot click mouse left. At the same time, the OLED briefly displays the word click to indicate that the click action has been performed successfully. Now upload the code to the ESP32C3. When I power up the ESP32C3, the OLED displays the message starting. After a few seconds, it displays Share BLE mouse, indicating that the device has successfully initialized. The ESP32C3 then automatically reconnects to the laptop through Bluetooth low energy, allowing it to work as a wireless mouse without a manual pairing it again. If you don't know how to pair a Bluetooth mouse for the first time, don't worry, I will guide you through the process. First, open the Bluetooth setting on your laptop. As you can see, the XIAO BLE mouse is already paired on my system. If you are connecting it for the first time, click on Add Device. Then select Bluetooth. After a few seconds, XIAO ESP32C3 Bluetooth mouse will appear in the list of available devices. Simply click on it to pair and connect. Now you can see that when I move the joystick, the cursor on the laptop also moves smoothly in real time. The XIAO ESP32C3 is successfully working as a wireless Bluetooth mouse. As you can see, I can now control the laptop using only the joystick. I am opening and playing videos on YouTube, changing videos, navigating through the screen, and even moving forward and selecting different options, all wirelessly through the ESP32C3 Bluetooth mouse project. Every time I press the joystick button to perform a mouse click, the OLED display also shows the text click. This provides a visual indication that click command has been successfully sent from the XIAO ESP32C3 to laptop through Bluetooth. And with that, our Bluetooth mouse project using the XIAO ESP32C3 is successfully completed. In this project, we learned how to create a wireless BLE mouse using a joystick and an OLED display, allowing us to control a laptop completely wirelessly. If you enjoyed this project and learned something new, don't forget to like the video and subscribe to the channel for more amazing ESP32, Arduino and IoT projects. If you have any questions or suggestions, let me know in the comment section below. Thanks for watching and I will see you in the next project.